Okay. What am I here? If you look at bee breeding, it's way more complex than working with most other animals. You're dealing with this superorganism. If you look at a colony, you've got all these different subfamilies. They're represented by a group of worker bees fathered by different drones. Some of those will have a propensity for certain traits like maybe hygienic behavior, pollen collection, different things like that. You also have an age distribution of tasks, like young bees, nurse bees will do the inside colony, the feeding, brood care, and as they age, you go into foragers and then guard bees, things like that. So there's an age distribution, but there's also a genetic propensity for different type of traits. And then you have the impact of the environment, which is huge. If you look at this superorganism, it's dynamic, it's flexible, it's responding to the stimulus in the environment, which makes them very adaptable. So when you look at bee breeding, our whole goal is we want uniformity, we want consistency. And the whole strategy of honeybees is that diversity. Their fitness is based on diversity. The more diversity you have within the colony, the more fitness you have, the more ability to adapt, change, take advantage of your resources, changes in the environment, new pests being introduced, whatever that is. So I think if you really look at breeding other animals, honeybees are probably the most difficult. And if you look at the progress over time, I think our progress has been much slower than if you look at milk production, egg production of different domesticated animals. So from a beekeeper's point of view, if you look at that complexity, my goal was just to simplify it. I'm not going to try to figure out all these different traits, how they figure in there, but it's just whatever causes that good performance, I want that in my population. So this is a very simple selection process that I use. For example, what makes good honey production? It could be the egg-laying rate of the queen, longevity of the workers, many different factors there, their adaptability to that resource, whatever that is, you just want that in your population. You want to select bees that are well adapted to the environment. For example, if you're working with a cold weather bee, you don't want to put a temperate climate bee in that environment with those kind of results. So that's kind of like the background of this. When I was at UC Davis, Page and Laidlaw were developing their closed population system, and that really intrigued me because it's kind of what beekeepers have been doing all the time. You pick the top performing colonies and you select off of those and breed off of those. But this was a little bit tighter. It's looking at keep it within this closed population, looking at it over time. And what you're trying to do is increase the performance, increase the consistency over time, basically. So this is kind of a little history of where this started from. I started in the early 80s as a small business, just doing queen production basically, and we chose carniolans because it was something a little different. Most of the commercial operations were working with Italian bees, so I thought, well, at least with my little insemination instrument, I could keep them black. So they'd be some unique thing. And then I moved into various universities, taking that breeding program with me, which was really nice because if you look at breeding, it's very labor intensive, it's very costly. So somehow I managed to get these universities to pay my salary while I kept this thing kind of going over time, which is a little goofy, but there was not a lot of big interest in bee breeding at the time. We didn't have varroa, we didn't have all these pests and predators and diseases, and most commercial beekeepers would just select colonies from their operation, and that was sufficient. In the U.S., where we have a pretty mongrelized population, if you look at Italian carniolans, they're not very distinct like you'd see in Europe and some other countries, or even here maybe. So I moved this from Ohio State University to Davis, California, and more recently to Washington State University, where we're more focused on increasing the genetic diversity, importing germplasm from Europe to, honeybees aren't native to the US as they aren't native to here, Australia. So you have this small subset that was initially brought in to create this huge industry. So if you look over time, there's some bottleneck effects of that. And also, do we have enough diversity in that gene pool to deal with pests, diseases, pathogens, which are constantly changing, especially with Varroa here now. So those are big considerations over time. Again, the new word carniolan, just to give it a name, just to make it distinctive, that was kind of something different from the general Italian population in the US. Again, this goes back to the early 80s. And to do that as a small business, it had to be very simple. Had to be, you're just looking at general productivity over time. So basically, I'll just kind of go through the theory, the Page-Laidlaw theory. They did a computer model. So if you start with 50 queen mothers, 50 different colonies, fairly unrelated, they figured you could go 20 generations with this. If you're doing selection, if you have a smaller population, say you have 20 breeders and not 50, what you do is you would take a daughter from each of those different mother colonies just to keep the more integrity in the gene pool. We went throughout the US, throughout Canada, collected this stock, and it was fairly mixed up. Back-crossed it to get a more carniolan-like bee, looking at more carniolan characteristics. They're much more conservative than Italian, things like that. The early shutdown, things of this nature. So from that, we took those 50 breeders, you propagate them, and then I would take drones from all those 50 colonies, mix the drones, and inseminate daughters of those queens. So then you make a test population of 200-300 colonies, and then you select the top 50 of those. So you do this generation after generation. That's basically how it works. So it's a closed population in the same sense that a beekeeper would be selecting when there's operation, but by doing the insemination, you just tighten that up and you really know what you have in there. But in the same sense, to expand that gene pool, I'm always looking around who has carniolans. And I would buy a handful of queens, put it in a separate yard, look at those, and I would take, if it was something that looked a good performance, I would take a handful of those drones and then throw that into my population. So you don't have a huge change in the population, but I'm getting more diversity within that gene pool. Does that make sense? It's really easy to bring stuff in. It's a lot harder to, if it's something you don't want, it's much harder to get it back out. So I would just take a handful of drones and look at that population pretty tightly. I didn't want a big change in the population over time like that. So for example, I got some Canadian stock that had a little bit of chalk brood in it. It took way longer to get that chalk brood out than it did to get it in, things like that. So you just do a little bit more cautiously. So basically, we would have this, I'd pick out my breeders, have my 50 breeders, do the test population. You've got this nice gene pool to look from, collect the top 50. So you're just kind of looking for more uniformity, more consistency in that population over time. But the key to that is maintaining that diversity within that population. If you get too narrow, you're going to just have a general loss of vigor. So it's really important. Instrumental insemination, this is, I don't know why, but when I was early in college, I took a lot of interest in this, and it's been a nice tool to have. It's not something every beekeeper needs, but if you're doing any kind of breeding work, you really need some method of controlled mating, whatever that is. If it's isolated mating, just some way to control that gene pool, because every time that queen goes out to mate, you're going to lose 50% of that selection you've made unless you can do drone saturation or unless you can control that drone population to a degree. You may have more opportunities for isolated mating here. In the US, it's pretty difficult for us. So And you can do amazing things with that. You can store the semen. These are little tubes of honeybee semen. You can hold it for about 2 weeks at room temperature, which is amazing compared to mammals. I'll talk about this a little bit later this afternoon. But it's an amazing tool. You can do things that don't happen in nature. You can do single drone seminations, or you can take like 100 drones and mix it up and give that and separate that out to a batch of queens. So you can do really extreme things like that, which are pretty interesting from a research point of view. Basically, the goal in general was just to make a good, hardy, productive population. Carnies are known for their winter hardy, very gentle, productive. We were just trying to maintain that, just trying to keep that in the population. But as time went on, tracheomites, I don't know if you guys, how that happened here, but when we first got those in the US, I think that was that 82, 84? Someplace in there. Anyway, but it was devastating. There was a big eradication program, and there was a big collapse of colonies. But in the literature, it was really confusing. How big of a problem is this? So I just took the losses over about 2 winters, and after that, it wasn't an issue. We don't look at tracheomites at all in the U.S. across the board. It's resistance to tracheomites is a dominant trait. So if you just let it go through the population, it will clean out the more susceptible bees. Okay, Varroa is a whole different ball game. We all know this one. It jumps species. We don't have a lot of known mechanisms that our European honeybees can deal with that. We know some of them: grooming behavior, hygienic behavior. There's a brood pheromone, caromone attraction. For example, if you put a frame of brood, give a colony a frame of African brood versus European brood, the mites will favor the European brood over the African. African brood has a faster development time, and they can tell the difference between those things. So there's a lot of opportunity here to select for resistance to Varroa. Keep in mind, we've had this for 30 years in the U.S., and we haven't made a lot of gains. We know the olfactory cues, the hygienic behavior is really a sensitivity. Can they smell something in the brood that's not right? Can they can tell the difference between the reproducing mites in the brood, and they'll clean that out. So that's really an important factor. Other things, nosema was kind of a minor issue. Nosema ceranae, they changed that a little bit. It's as Dave Mendes mentioned earlier this morning, it's quite variable. It jumps around. You can see those levels go up and down. It seems to be stress related a lot of the time, more than seasonally. Deforming virus, some of these different viruses associated with mites. When I moved my program from Ohio, and I got pretty comfortable with Varroa there, and this was 2007. And then I moved to Davis, California is a big beekeeping state. A lot of migratory beekeeping moving in and out of there. It's almond country. And I swear those mites were bigger and more virulent, and wow, they just surprised me. But it's really I think it's the pathogen loads associated with the mites we have less tolerance of Varroa mites. You do more damage at lower levels. And I think it's the pathogen loads that really is the big issue there. So I guess what I'm saying is things are changing all the time. You just have to monitor those colonies, look at that. But if you're going to breed for any kind of resistance, the bees need that association. And I think what we've done with Varroa put a lot of pressure on the mites to deal with our arsenal of chemical controls. Okay, we've run out of the chemical controls that work anymore, so it's really time to look at breeding. So I think right now there's a lot of interest in that, a lot of focus on that. We have a lot of new tools. If you look at molecular genetics, it may be some, molecular modification of something that will give us a little bit more ability to deal with that. But just keep in mind, these things are dynamic, changing all the time, not just the bees, but the pathogens, everything associated with them. The environment we live in, we have all these chemical residues they're exposed to. When you combine a few of those and you get more of a synergistic effect and they become more of a problem. Environmental change, with the development of land, we're losing a lot of our forage, or it's changing with climate change. So a lot of things are just changing all the time. So you really have to kind of give a heads up to all these things. So back to this is a really simple selection program, and it was pretty much based on, initially starting this in the early 80s, we didn't have all these problems, we didn't have all these issues, but what I'm saying is you've got to be sensitive to that over time and change, adapt as the bees do. So this is just kind of a 3-step process. We'd look initially at just establishing the queens. I'd inseminate the batch of queens, get my test population of 200 colonies established, and you want these all to be uniform size of colonies, uniform age, so that you can kind of compare them, and it's kind of a comparison test. And then we look at, how do they build up? How do they produce? How's the overwintering ability? Just looking, kind of scanning the population and looking at that. And then testing for, once you do your selection, you have your major cut, and then you start looking at more specific things like hygienic behavior. What's going to give them more ability to deal with the pests and diseases that they're working with. The hygienic testing is a little bit more labor intensive, so I want to make a cut in that population initially. So, and you want to do, instead of putting little pluses and minuses on the top of the lid and the lids get switched around, you want to keep it really simple. We do a really simple scoring method, just looking at these different traits. You're running through the colony, looking at brood viability, temperament, buildup, how many frames of bees are these, 4, 6, whatever that is, and just giving them a point value. And usually it's the same person doing that, because if you have a different person doing these things, you'll have different scores like that. So usually it's the first few hives that will kind of set the tone for that. My system now, I go 1 to 3. I've even simplified it more than that now because things are a little bit more uniform. You're always looking for diseases. You're always looking for anything abnormal. And we'll give that a negative value if it's like maybe 1 or 2 cells of chalk brood or something like that. Or you can just eliminate it. If it's something like foul brood or something more serious, you would just eliminate it at that. We're also looking at mite drops and things like that. But you just want to, basically you're just kind of scanning the population and you want to rank the colonies. You're just looking for the best performance. And those colonies usually stick out. They're usually the ones, ooh, wow, look at this one. So it's pretty subjective most of the time. So the pre-selection, these are usually a single deep, established. It's kind of late spring. Just go through and you look at brood viability. How solid is that brood pattern? I'm not taking a square and measuring, all the empty holes in that little place. I'm just kind of scanning a couple frames. I mean, you could have a lot of pollen coming in, they're plugged out with pollen or nectar or something like that. So you just kind of roughly scan several frames and look at the brood pattern. How solid is that brood pattern? And that gives you a good indication of how diverse your population is. If you're seeing spotty brood, you have a problem. You need to start bringing in some more stock or trying to augment that population, enhance it with something. Again, every time you bring something in, you kind of dilute out what you selected for. So it's kind of this little balancing act you have to constantly do. If you get too comfortable and just kind of let it go, it's going to kind of slip back into mediocrity. So it's a constant maintaining selection pressure on that population over time, basically. Temperament. Can I just go through those colonies and the bees are nice and calm? Are they runny, a little nervous? Are they flighty in my face? Am I getting stung? Or, so you just give it a score. And you can, if you have a population that's a little more touchy, you could give that, you could count that higher, or you can put more emphasis on that, or whatever, you're trying to change or move it into. So again, it's flexible, it's dynamic. Colony buildup is usually coming out of winter. That's a real, you can see a lot of differences. Is this 4 frames of bees, 6 frames of bees, 8 frames of bees, whatever that is? And it usually correlates to something else. It could be nosema problems in one of those colonies. Why is that population smaller? Why is that population not building up? It's usually something like that. But instead of going through and looking at all these details, I'm just picking out who's performing the best. I don't care about the details. I'm just scanning that population. The game here is you want to get through all those colonies on the same day in the same environmental situation. If I got different yards set up, I'll score one yard and then score this yard different, because you may have really different environmental conditions there. Maybe this has a little trickle of some resources coming in. Maybe this one is more pollen starved for whatever the situation is. So you want to kind of score them a little differently. And then you can compare the top of each of those performances. So once I go through the pre-selection, that's mostly looking at brood viability, temperament, or looking for problems. And then the ones that within that don't look good, you can make a cut there. Then you go into performance. You build the colonies up, you take them into honey production, and we do just a weight gain test, which is, instead of trying to figure out which box came from which colony, we just lasso each side of the colony, get a rough score there. You may have different weights, and maybe one's more saturated than the other, but Tibor Szabo in Canada developed this little test. He showed that that weight gain over the season is correlated to short-term weight gain. So if you look at that weight gain during a short period of time during the honey flow, that'll correlate to the season. So maybe you don't have a good honey flow every year. Maybe you don't do this test every year. It doesn't matter. But if you have a good honey flow, that's a nice time to do that test. Winter, I think this is my best selection tool. It really sorts things out. You want to make sure they have enough food going into winter, but how they come out of that winter really makes a big difference in I think, pathogen loads, virus loads. I could test for all the different viruses, but that's incredibly labor-intensive times a couple hundred colonies. So I'm just looking at who's coming up the fastest, who looks the healthiest after that winter. And you just take a frame count. Again, you just roughly how many frames of bees. Part of that is having the drones come up. It's just really simple. It's just kind of scanning that population, just looking for who's performing the best. And that once I have my population here, these are nice and uniform. I want to go through and let's start looking at varroa or pests and diseases. So we do the hygienic testing. This is we know that if you kill a section of brood and how fast the bees remove that correlates to disease prevention. But it's an olfactory cue. You're selecting for bees that have a really strong sense of olfactory. They can smell something's wrong under that cat brood, and they'll clean it out. That could be one subfamily. You may have another subfamily that goes back and recaps it. You can have all kinds of goofy things going on here depending on, when you start selecting for single traits like that. But in general, we're just looking for who does this job the best. This is, we pour liquid, this is just a piece of PVC pipe, and we pour liquid nitrogen in there and let it freeze a section, and then leave it in there. Initially, we did 48 hours. Now we do 24 hours, because it's really those bees are super sensitive, and they should jump on that immediately. This is one that you can see it's completely cleaned out. You get all different degrees of this. You get some that just uncap, but don't clean out the larvae. Just variations on this. I have some really. When we did this, we got about 70% of the population would show this trait, but I would have some good colonies that you would still have a little bit of residual dead brood in there. If it scored really high, but didn't have hygienic behavior, I would not necessarily eliminate that. I just score them and I take the top section of those. It's one trait. Maybe that colony has some other trait. I've seen colonies that did not score hygienic, but the mite drops were less than, had lower mite drops for whatever that reason is, I don't know. But whatever it is, I want that in my population. Grooming behavior is another one that can be confusing, so it's when the bees will groom those mites off, so you should get a drop for that. Sometimes we'll look for mites that have the carapace or their legs bitten. That's another indication of grooming behavior. So you're just always looking for little traits, little indications. If when you're looking, I have, is that in the next slide here? Maybe I have it in the next slide. I have these screen bottom boards in here, so I look at drop, and if you need to do that like kind of over the season. It'll change over time, but it's like if you have a colony that keeps a fairly high mite drop over the season, then that's a cause for concern. Maybe you want to eliminate that queen. If you get a big emergence of of brood, sometimes you'll get a higher drop than normal, so you really need to kind of look at that over the season. And I used to count them, have little squares and count them. Now I just kind of do a rough estimate, what's the mite drop there. I'm in Washington State, kind of a northern area. There's not, we do have some seed production there, but there's not a lot of commercial beekeepers around me. There's not this big influx of bees, commercial bees all the time. So I can get pretty relaxed with this. I treat between New Year and Christmas. I use HopGuard. Hops is a miticide. Do you guys have access to that? Maybe, I don't know if you do or not. HopGuard? No? It's kind of a marginal thing. And then usually August is 2 minutes. Ooh, okay, I'm going too slow here. In August, if I find a hot spot of mites, I'll use a Thymol, Apiguard, things like that, and then requeen the colonies. I'm breaking down colonies a lot to make up nukes, so breaking the brood cycle is one of my good ways to do it. So basically, we select the top performers. You're looking at consistency, productivity, and you want to try to push that population to be more resistant to pests and diseases. Try to go through this a little quicker. Top performers. I'm only doing the breeding stock, so it's really essential that I partner with the commercial beekeepers, supply them with breeders, and they're propagating those and supplying those to the commercial industry. So that's really a key element in there. Again, a major focus is pests and diseases. We talked about that, so I'm going to kind of jump this one a little bit. Hive beetles, do you have these guys yet? In my northern area, I've only seen maybe one or two. It is a tropical pest, so I'm not going to go into that too much. Again, I mentioned some of these things. We're dealing with a lot more pests and diseases than before. Trying to get bees on natural forage is getting more difficult to have good nutrition. If they don't have good nutrition, they're going to be more stressed. They're going to be more vulnerable to residues, agriculture residues, miticide residues in the environment. So that's really increasing problems, challenges, I guess. Again, looking at these bottleneck effects, this is a kind of a line breeding system, and when you have a close population like that, you got to be really careful about, do I have enough diversity in my gene pool? Do I have enough diversity so if you get something else, so like Tropoalaps, another Asian mite, what if that comes in here? Do the bees have enough diversity in there to deal with that, to develop those kind of things? So what we've done is we brought in germplasm from Slovenia and Germany. We bring in semen only. Semen's a little bit safer. Viruses can travel in that, but we have a quarantine area. This is pictures of Slovenia. They have these nice little bee houses. We have a quarantine area. Oh, this is a shot from Slovenia. They have these, there's a resident bear here, so the mating nooks are caged, which is kind of cute. This is the drone colonies are up in here, and there's a little place. This is high in the mountains where they breed their isolated mating. So they have a little house here where they can sleep and eat and take care of things. Try to go through this quicker. We do a quarantine. The semen comes in, and we set this up in an isolated area. It's basically wheat fields. So there's no, and we test the semen for viruses. We do progeny testing on top of that to make sure we're not bringing in something that would be detrimental to the industry. And that's all controlled by this is our Department of Agriculture, and this is Plant and Animal Protection Service, so it's under that. And then once they release that, then we can propagate that and provide it to the industry. This is Megan Taylor's work. She's going to show this a little bit later in the scientific section, but I just want to go over this really quickly. This just shows the lack of diversity or the declining diversity in our U.S. breeding stock. So what she did is measure, take samples of the breeding stock in the U.S. in '94. This is Debbie Delaney's work too. 10 years later, and then more recently, you can see that this is just general decline in the population over time. What the difference is here is these are beekeepers, queen producers that did not incorporate the germplasm into their gene pool. These are beekeepers plus that did incorporate the germplasm we brought into their operations. You can see this big jump in diversity, which diversity is fitness, basically. Okay, go to Megan's talk this afternoon if you want to hear more about that. We feed the world. We are responsible for pollination. This is really critical for our food supply. And so I think it's just really important we have healthy, strong, vigorous bees. So thank you all guys for helping with that process. So thanks.